Welcome to the next chapter of Moment Math, and today we are gonna talk about modular arithmetics. There are a couple of sections or topics I'd like to go over. First, modulo, congruence, negative numbers. I'll explain what a minimal subset is. I'll explain how to do modular addition, subtraction, and multiplication, and finally modular division. So let's get started with modulo. What is modulo? So first, modulo or modulus is a fancy word for remainder. So basically, let's say I want to divide 7 by 5, or I could write it like this, right? 7 over 5, it would be 1 with a remainder of 2, right? Because how many times does 7 fit in 5? 1 time, and then I have a remainder of 2. Right? And that's what the modulus is. That's the remainder. So let's say so the way to write it in a mathematic way, we would say, what's 7 in modulus 5? And the answer would be 2, because that's the remainder after division by 5. Okay, so it's nothing very complicated. Modulus is just a plain old remainder after dividing a specific number. The next very important term of modular arithmetic is congruence. Congruence. It's written like this if I were to write something. I'm not saying that this is a correct statement, but it's denoted by an equal sign with an extra line. So it has something to do with equality in a way, but doesn't at the same time. So what does congruence mean? It basically means it means two numbers that are equal in a way. They have the same remainder after being divided in a specific modulus. So let's say that so we already know that 7 modulus 5 is gonna be 2, right? So that's the remainder 2. And what is 2 in modulus 5? Well, 2 divided by 5 is 0, and the remainder is 2, right? So is it fair to say that 7 is congruent to 2? I think it is. So that's basically what it is. Number 7 is congruent to number 2, and I should also note in modulus 5. Okay, so altogether I would just say 7 is congruent to 2 in modulus 5. Okay, and in a shorter way I would just say 7 is congruent to 2 modulus 5, something like this. Did you notice a fun fact that I actually got the answer when I was calculating modulus. Well, that's kind of interesting. When you divide 7 by 5, you get the remainder 2, right? And then, so the remainder, what can the remainder in modulus 5 be? What can it be? It can be anything up to 4, right? Any number up to 4, 0 to 4. You either have no remainder, or you have a remainder of 1, 2, 3, or 4. Otherwise, you could divide again by 5. So it's interesting that if we take the remainder, that number is actually always going to be congruent with the original number in the modulus. Because when you take the remainder and you divide it, like if I take 2 and divide it by 5, that's always going to be 0. But the original remainder, so the number itself, is going to be left over. So that's a nice thing to kind of remember. But yeah, congruence, I know it sounds super complicated, and it takes a little while for it to kind of click, as the whole modular arithmetic does. But congruence is basically equality of two numbers in a specific modulus. So it basically says these two numbers, like number A and number B, modulus. So it basically says that number A and number B have the same remainder when divided by number X. So for our example, number 7 has the same remainder as number 2 when dividing by 5. So number 5 is X, right? And I already started talking about it a little bit, but the next topic I wanted to cover is minimal subset. So let's go 3 and talk about minimal subset. Okay. What is the minimal subset? That's all possible remainders that a number can have. So if you're dividing by 2, then the minimal subset would be really bad at drawing curly brackets, would be 0 or 1, right? And let's prove it. So let's say I want to divide 1. 1 divided by 2 would just be 0, and the remainder would be 1. But 2 divided by 0 would have a remainder would be 2 divided by 2, what am I doing? 2, not 0, would be 1 with the remainder of 0. Okay, so that's the only remainders I could have here. So what would be a remainder after dividing by 5? So modulus 5 would have 0, 1, 2, 3, or 4 remainder. So that's so this right here is the minimal subset. 0, 1, 2, 3, and 4. That's essentially all remainders I could possibly have. All right. Now let's move on to another topic. These are pretty quick so far. So the next topic would be negative numbers. Because it's not so clear as to say what's 17 divided by 5. Or no, let's not divide it by 5. Let's say what's 17 in modulus 5, right? We want the remainders. We don't want to actually divide anything. So the closest I have is like 15. So I would like split this thing up to minus 15 and minus 2, right? That would give me minus 17. So I can see that I would divide it and it would give me the number 3, which I don't care about because I just care about the modulus or the remainder, and the remainder is minus 2. But wait a second, this is a negative number, so my answer wouldn't just be minus 2. And there are like a couple of techniques to deal with this. So the first that I like to do is you gotta remember that before you start dividing, before I start this operation, I would basically flip the sign and I would say, oh, let's just do 17 modulus 5. What would that be? Well, I know that would be 2, right? Because 15 divided by 5 is has a remainder of 0, and then I have the overlaying 2 that I can't divide anymore, so that's my remainder. So I flipped the sign, so I flipped it to plus, and now I have the remainder and I need to change it back to minus, and then I need to add it to the modulus, which means, so this whole thing would be minus 2 plus 3, sorry, I'm getting ahead of myself, plus 5, which would give me 3, right? And that this would be our final answer. So minus 17 modulus 5 would be 3. Another way of thinking about it or solving it is you keep you can keep this the minus sign, and you ask yourself, how many times do I have to multiply to get to a positive number, essentially. So how many times do I have to multiply 5? So 5 times, let's say, a is gonna be bigger than minus 17. Minus 17 is gonna be larger than 0 when I subtract minus 17. And the answer would be 4, right? 5 times, because 5 times 4 is gonna be 20. And if I could say 20 minus 17 would give me 3, right? And that's the same remainder that I worked out a little while ago using flipping the signs. Okay, the cool thing about modulus and modular arithmetic is that you can like make up as many examples as you want for to practice, and you don't need to rely on books and worksheets. So let's say that of course, bigger numbers I would want to use a calculator because it's just simpler. But let's say that I want to say 12. What's 12 in modulus? Let's say 7, for instance. Do you know what that is? So 12 divided by 7, so is gonna be 1, right? And what's left over? That's 5, so it would be 5. 5 would be the remainder. Okay, and what about minus 12 modulus 7? Well, for that I would first flip the sign, so I already know that positive 12 modulus 7 is 5, right? What I just need to do is to flip the sign back again. So I would do minus 5 plus 7 be 2. That's my final answer. So minus 12 modulus 7 would be 2. And we can try the other technique just to practice both of them. So what's the number, what's the result of multiplication by 7 that would that when I subtract minus 12 would give me a positive number? And I would say that it's 14, right? Because 7 times 2 is 14. So if I say 14 minus 12, it's just gonna be 2. And I get the same answer. That's my remainder for the negative number. Okay, we can try one more example. So I can say, for instance, 27 and modulus 4. What would that be? So I know that 28 divided by 4 has a remainder of 0, right? So because 28 divided by 4 is going to be, what, 7, right? With remainder of 0. So if this number is one less, then I know that the remainder must be the maximum remainder it can be, right? So it's going to be 3. Similarly, minus 27 modulus 4 would be minus 3 plus 4, and it would just be 1, right? And now I can say, no, let's talk congruence, for instance. Let's talk congruence. So now I can say that minus 27 is congruent to 1 in modulus 4. Because if I divide 1 by 4, my remainder is going to be 3. Because it's 0, and I have like, my remainder is, oh wait, 1 second, I got tangled into it. I'm just talking about these cases, not the top. So minus 27 is congruent to 1, and 1 modulus 4 is just 1 because I can divide 1 by 4. And in the same way, minus 27, I would of course need the next one, which is 28 minus 27, and that would just give me number 1, just to verify that that's my remainder. Similarly, 27 in modulus 4 is 3, so I know that so I can safely say, let's put this in blue color, I can safely say that 27 is congruent to 3 in modulus 4, right? Now you're probably asking, are there more numbers that are congruent in modulus 4? I think so. I think there must be, right? I have number 3, that's the lowest. That seems lowest because it's lower than 4, which is the modulus. But let's go higher. What about number 4? Number 4 would have number 4 divided by 4 would have a remainder of 0, right? So I can't use that. Number 5 divided by 4 has a remainder of 1. Number 6 divided by 4 has a remainder of 2. So I can't use any of these. All of these are bad. What about 7? 7 divided by 4 is going to be 3. It's going to be a remainder of 3. That's great. So now I could technically say that 27 is congruent to 7 in modulus 4, right? Or I could say that 7 is congruent to 3 in modulus 4. Because I know that these numbers all have the same remainder. All right, let's look at the topics I wanted to go through. Addition and subtraction. Now you're gonna start to understand why I went through explaining the minimal subset. Let's go through addition and subtraction. All right. The way addition and subtraction and any other modular operation works is that you first have to get numbers out of the minimal subset. You need to remap numbers to the minimal subset, and then you do the given mathematical operation. So let's say that I wanted to calculate 16 plus 7 in modulus 4. Let's stay in modulus 4, right? So I would first have to remap it because both of these numbers are over the minimum subset. What's the minimum subset for number 4? That would be, I can write it in green here. That would be 0, 1, 2, 3, right? So I need to add these numbers. So let's first find the congruent numbers from minimal subset of these two numbers. And that's very easy, right? Because we can just essentially calculate it and it'll pop back. We'll just calculate the modulus and we'll get the smallest congruent number. So let's break it down and let's first do 16 in modulus 4. And 16 divided by 4 is 4 and the remainder is 0, right? I think that's pretty clear. And then 7 modulus 4 is 3. We worked it out up here. 7 is congruent to 3, and that's the smallest, that's the remainder. Right, which means that 16 plus 7 in modulus 4 can be converted to 16 plus 7, we would work it out to 0 plus 3, which of course is just 3. So that's our final answer. So 16 plus 7 in modulus 4 is just 3. Okay, let's do some other example. Let's say for instance 17 plus 13 in modulus 5. What would that be? Both of them are higher than number 5, so we'd have to work them out first. So 17 in modulus 5, which is gonna be 2, because we have 15, that's the closest. 15 is closest to 5. 15 is the closest divisible number when dividing by 5. And the leftover would be 2. And then we have 13 modulus 5, which is 3, right? Because I divide by 10, that has a remainder of 0, plus 3 that I'm missing. So this would convert to 2 plus 3, which is gonna be 5. And now here is a kicker. Now, if you get an answer that is not in the minimal subset, you have to remap it again. So our final answer wouldn't be 5, but 5 divided by 5 in modulus 5 would just be 0, right? Because the remainder is 0. So we need to basically remember to always remap to a number, a congruent number in a minimal subset. Let's do another example. It's good to do a lot of these, and I encourage anyone. I do that all the time. I just look online. I just Google modulus addition, subtraction calculator, something like that online, and then you can easily verify that your calculations are correct. So let's just do 16 plus, I don't know, let's say 4 in modulus 6. So here we can see that number 4 is already in a minimal subset, so I don't have to do anything about it. And number 16 is not. It's higher than 5, which is the last number in the minimal subset of modulus 6. So I would just work out the 16 modulus 6. So let's see. So I have 6, then I have 12. The next one is 18. So the answer is 4, right? 12 plus 4 is 16. So I'll get my number back. So the answer would be 4 plus 4, which is 8. 8 is not part of the minimal subset, right? If I work it out again. God, my brackets are crazy. Okay. 0, 1, 2, 3, 4, 5. That's my minimal subset. And 8 is not part of it. So what's 8 in modulus 6? Well, that is just 2, right? Because I divide by 6, I get 1. Because 6 divided by 6 is 1. And then I have 2 left over remainder. So it's 2. My final answer is 2. And of course the subtraction is exactly the same. There is no magic in it. So I can just do 25. What's 25 minus 13 in modulus, I don't know, 4, for instance. Our favorite modulus 4. Maybe I should do modulus 3 just so we have some change here. Let's do modulus 3. So none of them are part of the minimal, belong to the minimal subset, so I'll just work out 15. 15 in modulus 3 is gonna be, 25 in modulus 3. So 24 is the next neighbor that I can divide by 3. So my leftover number is gonna be 1. And then we have 13 in modulus 3, which is actually also just gonna be 1, because 12 divided by 3 is 4, so just add 1. So, and 1 minus 1 is 0. That's gonna be our final answer. Okay. We can do, for instance, 11 minus 14 in modulus 8. So let's work out 11. 11 in modulus 8 would be, it's 1 and 3. So 8 plus 3 is 11, right? And then I have 14. And I know that 16 divided by 8 is 2. So which means that my remainder is just gonna be 8 minus 2 essentially, so it must be 6, right? So 3 minus 6 would be minus 3, and that is our final answer. The answer would be minus 3, but since it's minus, I would have to flip it, right? So minus 3 plus 8, which is my modulus, would be 5, and that's our final answer. All right, next moving on to multiplication. Multiplication works exactly the same, except that the operation is just gonna be a multiplication, unsurprisingly. So I could do, what is 11 times 5 in modulus 5? So none of these numbers are part of the minimal subset. So I'm just gonna work them out. So 11 in modulus 5 is gonna be 1, and 5 in modulus 5 is 0. So 1 times 0 is 0, so our final answer is 0. Let's do some other one. Let's see, 2 times 3 in modulus 6. Well, 2 times 3, both of them are part of the minimal subset, so I can just multiply, which 2 times 3 is just going to be giving me 6. So 2 times 3 is equal to 6. And 6 I have to remap because it's not a part of the minimal subset of modulus 6. And when I remap it, it's going to remap to 0. And we have a lot of zeros. That's unintentional. So let's do something else. 2 times 7 in modulus 6. So 2 is part of the minimal subset, so I don't have to do anything about it. And 7, I have to work out. 7 in modulus 6 is just going to be 1. So 2 times 1 is 2, and that's our final answer. Now let's, we can do one more. Let's see, 14 times 8 in modulus 5, for instance. So we have to work out both the numbers. So 14 in modulus 5. You can see that I'm just missing 1 to 5, so 5 minus 4 is just minus 1 is 4, so that's going to be 4. And then to work out 8 modulus 5, which is gonna be 3, right? 3 plus 5 is 8. And 4 plus 10 is 14. So 4 times 3 is 12, right? And that's not in the minimal subsets, so I would have to work it out, remap it again. Modulus 5 is gonna be 2, and that's our final answer. Let's see, let's talk about division. Division is a little bit different and it's a little trickier. Like, let's say that I wanted to do, I don't know, I wanted to divide 6 divided by 2 in modulus 4, right? And the way you do the division is that you have to first find a multiplicative index. What is a multiplicative index? Now things are getting a little tricky. Multiplicative index is a number which is, if divided by our number, it's gonna be congruent to 1, right? So instead of dividing by 2, we could multiply by this multiplicative index. And what do we want? We want, the rule for multiplicative index would be 2, and the number 2 in our case, the 2 coming from here, if we multiply it by x, then it's gonna be congruent to number 1. That's the rule. And does that mean that we always are able to find a multiplicative index? No. So not always can we do the modular division. Okay, that's one important thing to remember. And how do we find the multiplicative index? You find the multiplicative index by basically trying if it fits into the congruence equation. We can treat this as an equation essentially, and just take the minimal subset of 2, which is 0 and 1, and we essentially try it. We try 2 times 0, is that congruent to 1? Is that congruent to 1? 2 times 0 is 2 in modulus 4, and no, it's not congruent to 1. So 2 times 1, is it congruent to 1 in modulus 4? 2 times 1, no, it's 2, and 2 is not congruent to 1 in modulus 4. It's different, right? So for instance, now the number 2 doesn't have a multiplicative index. It's a very low number. So let's do, what if I did 6 divided by 4 in modulus 4? Oh, wait a second, I was supposed to try to find it inside the modulus 4, not the number itself. Let's see. 1, 2, 3. So I can keep going actually. So 2 times 2 would be 4, right? 2 times 2 would be 4, and that is equal to 0, which is not congruent to 1. scratch this. 2 times 3 is gonna be 6. And 6 in modulus 4 is gonna be 2. 2 times 4 is gonna be 8. And modulus 4 is gonna be this is not gonna work out for us because it's 0. So 0, 0. 2 times what am I doing? This was the highest number. So 2 times 3 is congruent to 2. Yeah, so this, for instance, is not ideal. So let's say we have another formula. Let's do 6 divided by 4 in modulus 4. So 4 times 0 is gonna just give me 0. 4 times 1 is just gonna give me 4. That's 0. 4 times 2 is gonna give me 8. And 8 in modulus 4 it has 0. 4 times 3 is 12. So this doesn't work, right? Doesn't work. What if I change to modulus 6 divided by 4 in modulus 5, for instance? So 4 times 0, 4 times 0 is 0. 4 times 1 is 4. 4 in modulus 5 is just going to be 4. 4 times 2 is 8. And modulus 5 is just going to be 3. 4 times 3 is 12. Modulus 5 is going to be 2. 4 times 4. 4 times 4 is 16. 16 in modulus 5 is 1. Oh, wait a second, that's 1. Okay. So 4 times 4 is gonna be congruent to 1. So that's great news. So the multiplicative index is 4 in modulus 5. Okay, so what I can do is just say that 6 times 4. And that would be my answer, right? So 6 times 4 is 24. 24 is not a part of the minimal subset, so I would express 24 modulus 5, which I'm just missing 1, which is 4. So the final answer would be 4. So 6 divided by 4 in modulus 5 would be 4.